So today I'm going to be talking about data science. Data science is sort of like a new term that's emerging in the industry now. Many of you may not have heard this term. I mean, previously people used to just say that let's do analysis, let's do some data mining, or they would say let's do some stats on the data. But data science is now emerging as a discipline which incorporates multiple fields kind of coming together. It involves computer science, it involves statistics, it involves good business judgment and good business data processes. So in this talk, I'll cover the main lessons that I have learned in my career at Google and prior to Google in terms of how people are using data to make intelligent business decisions and how it's helping organizations become competitive in the age of machine learning and machine intelligence. A lot of these are buzzwords, but in the end, if you're a company that's making a tool, a machinery, or a plane, your business is to make planes. Your business is to make tractors. And you have to figure out how data will help you make better tractors or sell them. And that's where data science comes in. So even at Google, when I think about machine learning it gets into our products. And that is what makes the experience of those products really amazing and exciting for our users. So there are 5 lessons that I'll be going through in this talk. I'll go through each one of them in detail. But the first thing I want to talk about is when you want to have a data-driven organization, it's important to build a data-driven culture. That's a very, very important first step. A lot of organizations don't really think this through, and they say, oh, we have hired some data engineers, we have bought this Hadoop tool, or we have this tool and that tool, and we are data driven, and we have sensors, and we are in IoT. Like people will throw all of these buzzwords without really realizing what business decision are they making on top of this data. So I'll be sharing with you some examples on how business decisions can be made and should be made with this data. So I'll start with the culture, creating a data-driven culture. Then I'll go into some capabilities that an organization needs, some business trade-offs that companies need to make when they're using data. And then we all live in a very competitive world. So if you in your company are doing data-driven intelligence or machine intelligence, your competition is also doing the same thing. So you have to iterate, you have to adopt and adapt very quickly. So I'll share some examples around that as well. And then lastly, data is an important thing. It gives you a lot of advantage, but you have to treat it very, very carefully in terms of security of that data and as well as protecting the privacy of the users associated with that data. So let's start with lesson number 1, which is about building a data-driven culture. So data-driven decision making is not same as decision-driven data making. You see that a lot. I see that a lot, where people will say, okay, I know what I want to do. I want to enter this market. Can you find me some data to prove this is a good market? Right? That's not data-driven decision making. Now, people like to say that I'm analytical, I'm data-driven. I'm not going to go talk to my business partner or my boss or my colleague unless I have some data with me, right? So you make up some data and you go into a meeting. See, this is what the chart shows. You see that funny comic strip from Dilbert. People just make up numbers, right? Because if that's the whole game, it's to look like data-driven, then you just look like data-driven. But you don't want to look like data-driven, you want to be data-driven. So you have to invest in creating that culture and call people out that are we just showing data here for sake of data, or is this the data on which we will really be making a decision, and we have to be very, very thoughtful about that. So I would say take that as a lesson as you start to create data-driven groups inside your company or in a particular product area in a particular region. Definitely start with this as the lesson number 1. If this doesn't go well, everything else won't go well. So there are 3 capabilities around data intelligence and data science. The first capability is collecting good data. Right? Now, people collect lots of data. That is not necessarily a lot of good data. Right? There's a lot of data you don't even know what's in it. So it's important to collect good data and see the trends This kind of really helps you understand what's going on. Are sales increasing? Are sales decreasing? Are user engagement increasing? Is the competition increasing? So really understand what's going on. Now, understanding what's going on is good. It gives you an understanding of like what environment you are in and what competition you're facing. The next most important thing is you predict what will happen. So if we were to launch this new product, if we were to introduce this new feature, or we were to deprecate this product, what would happen? So that's where machine learning and prediction comes in. Most people kind of end there. They say, okay, we have good data, we do good machine learning, but your company, your organization is not just interested in predicting the future, you're also interested in changing the future. This is where experimentation comes in. So you think that if we do this, that will happen. The way to test it is to set it up as an experiment and really see if that happens. And that's a key part of the discipline. When you think about hiring someone to run your data organization, it's pretty common you'll start with an engineer who knows how to organize data pipelines, who can do some Hadoop and MapReduce for you. That's great. That's a good start, right? You maintain some data, you have some understanding of that. Then you will say, okay, let me hire a machine learning person or a statistician so that I can do some prediction on top of it. So let's say you are in the IoT space, Internet of Things. So you have sensors, you have lots of sensors data, and now you're saying, okay, we will predict which sensor is going to fail, which machine is going to fail based on all of this data. That's good. Now you predicted that. Then you need to come up with the third capability, and this is that capability which is usually most lacking in many organizations. It's sometimes easy to find an engineer to write your data pipeline, to build a prediction model on top of it, or a statistician to build a model on top of it. But unless you have a clear, rigorous discipline around experimentation, you would be just drowning in data. Like you have lots of data, you'll have lots of prediction models, but you won't know what's really impacting your outcome. And your outcome is usually a business outcome. So I'll go into the details of each of these capabilities, and I'll share some examples from my experience in terms of how to do things right and what common pitfalls or mistakes to avoid. So when we think about building good data, one of the myths is that most of the energy goes into machine learning. But the reality is that a lot of energy in building data practice or big data discipline is in collecting good data, organizing good data, curating good data. Because you can't do any machine learning or any prediction unless you have good data. In a lot of organizations, you will find that they collect all kinds of data, but if it's not curated, if it's not clean, then machine learning can't save the day. So a data scientist would typically spend 80% of their time organizing the data and really understanding what's in that data, what each variable means in that data. With regards to machine learning, it's an age-old adage in statistics that correlation is not causation. So whenever you look at historical data, you will find all kinds of correlation in the data, right? I mean, the people would say that, oh yeah, on the days when solar flare is high, our sales increase. It's like, well, that's just correlation, right? There isn't much causation there. But on the days the weather is warmer, online sales, e-commerce sales are usually lower. And there is some causality there. The causality there is on good weather days, people don't like to sit indoor and do online shopping. They like to go outside. Even online casinos see a drop in their sales, in their winnings on the days of good weather. So if the weather is good around New York and in West Coast, all e-commerce companies in US will have a little bit lighter day that day because people will be outside instead of doing shopping inside or playing online poker. So you understand the causality there. And if you understand the causality, then it's easier to do the prediction. Then you can say that, oh, weather forecast says that this weekend is going to be beautiful. Well, then you may not see a lot of online orders. Well, this weekend looks like it's going to be pretty bad, a lot of rain, snow. I think people will be shopping online. They'll be at home, right? So that's where the power of prediction comes in, and it's important to understand what is really correlation and what is really causation, because causation helps you predict, correlation really does not help you predict. The third piece is around experimentation. So it's quite common that people will say that, oh yeah, I like experimentation, I'm very data driven, let's launch something, let's do something, and then we'll see what happens. Well, that's our experiment. That is not an experiment, right? You were going to launch anyways, and now you're saying we'll launch it and we'll see what happens. The experimentation is when you do a controlled experiment. In the medical field, they will give the real drug to one group of people and give a placebo to another group of people. So you have a treatment group and you have a control group, and then you compare what is the difference in the outcome. That is what a good experiment is. So having a treatment group and having a control group. Just launching something and saying that we'll see what happens is not an experiment. But people often say that we are experimenting, we're changing things, we are seeing what happens. So here are a few examples that I want to share with you in terms of common mistakes people do. So you see a curve like this. So there is sales on the y-axis and there is a price cut that happens at a certain time. And the sales are more or less flat, no change in the sales. So someone makes a claim that, well, demand is inelastic, right? So from economics, we all know that there is a demand curve, and if you reduce the price, there is more demand. If you increase the price, there's less demand. But here, it looks like it's flat. Price had no impact. So if you draw the conclusion that whatever product we have is inelastic. I mean, it does not depend on price. In reality, it could be that you were not collecting the data around what was the street price of your product. So you are a manufacturer that makes something and then you give it to your distributors or channel partners. So you decided to reduce your price by 20%, but your distributor did not reduce the price on the market, right? They just kept the extra margin. Obviously, sales will remain flat, right? So you have to think about what data are you collecting. Are you collecting your own price or are you collecting the market price, the street price? Because if you are collecting good data, then you will be able to find out the sales are not flat. Sales could depend very well on whether the price changed or not. Let's look at another example. So here you have on the y-axis time spent on a site or on a product. Like let's say I have an app or I have a website and I do a feature launch, and after the feature launch the time spent on the website increases. So now if you have historically thought that more time spent on the website means people are happy and more engaged, right? So that's like the correlation. If you understood that as the correlation, then you will draw the conclusion that feature is increasing user engagement. But on the other hand, if you were really careful in your tracking and modeling, you may find out that users are frustrated because now it takes them longer to do what they wanted to do on the website. So everyone goes and clicks on this button, you remove that button and hide it behind a menu. Well, now everyone is spending 5 more seconds on your website. Well, is it really increasing user engagement or is it just increasing user frustration? So this is where really understanding the correlation versus causation in your data can be helpful. Let's look at a third example. So here you have sales on the y-axis and time here on the x-axis, and you launch a new product and the sales increase, right? So someone will quickly draw the conclusion that our launch has increased sales. But notice the time here, right? It's the December time period. So the reality could be that it's the holidays that is causing the increase in sales, and the launch might have actually depressed the sales. But you wouldn't know unless you run an A/B experiment. So really, unless you have a control group, You would not be able to tell. This looks like the launch is amazing. It's increasing our sales. So kind of thinking about these three capabilities is really important if you want to be good in building a data-driven and a data science-driven organization. So the third lesson I want to talk about is data is not the answer, right? These graphs and charts are not the answer. You have a business, you have an organization, and you have to make some business decisions. And when you have to make a business decision, an example may look something like this. You have 100 customers, and 90 customers will renew their subscription, and 10 customers will likely cancel their subscription. Okay? So if we had a simple model that predicted that all customers will renew, right, or customers will always renew, it'll be accurate 90% of the time, right? 90% of the customers renew, so your model says everybody will renew. You are right 90% of the time. However, you are not able to identify the 10 that were not going to renew, right? Because your focus as an organization should be on the 10 that are not going to renew. Now, this is a very common problem. I mean, in a lot of business data, you're trying to predict something which is a unique event. So it's called class imbalance. You're trying to predict the class which is the non-renewal class. So what we need is an intelligent model, not just an accurate model. And intelligence here comes based on the business context. So let me go a little bit deeper in this example to illustrate kind of how would you think about building that model. So here is a pictorial. You have 10 triangles here that represent 10 customers that are not going to renew, and 90 circles here that represent the customers that will renew. So you build a prediction model, and that prediction model identifies these 11 dots, right? It identifies these 11. So you got a few positives, the true positives, like you wanted to identify who will not renew, and you identified 6 out of them, right? There are 10 of these, but out of 10 you identified 6 that will not renew. And you obviously know that these are the true negatives, right? Now what you have is you also have some false positives. So these red dots, you think they will not renew, I mean you are predicting they will not renew, but they will renew. So you have a prediction error. It's a false positive in your prediction. At the same time, you are missing these 4 triangles in your prediction. So you have a false negative. So it's hard to build a good model where you have no false positives and no false negatives, right? That would be perfect. So usually you have to make some kind of a trade-off. And the trade-off is made based on, these are technical terms, so you don't need to memorize it. The trade-off is usually done based on precision and recall. Now precision means that you made 11 predictions. Out of those 11 predictions, how many were correct predictions? So 6 out of 11 were correct. So that's the precision of your model. Recall says you wanted to identify 10 of them, but you identified only 6 of them. So that's the recall. And now you will have to think about how do I make a trade-off between, is precision more important to me or is recall more important to me, right? So here is how the problem becomes even more interesting now. So cost in a business setting plays a very important role, right? There is a cost of every action that you take. So let's say that the customers that were not going to renew, you were going to give them a discount. You will give them a discount to save those customers, right? So you will spend $100 per customer in giving them some discount so that you can save them. So there were 11 customers that you identified in your model. So you'll give discount to all 11 of them, and that will cost you $1,100. The benefit of that action is only for the customers that were really not going to renew. The others just got a free discount, right? They were going to renew anyways, but you gave them a discount, they'll happily take it. So the benefit is, let's say, $150 because you saved a customer and that customer is good for you in the long run. So if the benefit is $150, then you got the benefit from the 6 customers. So your total benefit is 6 times 150. That's like $900 of benefit. Now, everyone in this room can tell me that for this example, cost is greater than the benefit. This is not a good model. If we were going to go down this path and this is how I was running my business, I was running it into the ground, right? So what is more important? Is precision more important when you are predicting something, or is recall more important? It comes down to what is the cost of a false positive and what is the cost of a false negative. So as the cost of a false positive increases, right? A false positive is where I'm doing something when I really didn't need to, right? I mean, if the cost of the false positive increases, I need a very, very precise prediction. An example is if I was giving away a large discount, I want to be very precise who I am giving that discount to. I don't want to give that discount to everybody, right? On the other hand, if all I was doing was sending an automated email, that's fine. I mean, even if the precision is low of the model, it's okay. I don't have a huge cost for that model. So it's okay. I can sacrifice precision in that kind of a setting. Now, here on the right-hand side, the cost of a false negative, right? So false negative is someone I wanted to find in my prediction, but I missed them, right? There is a cost there. So I want very good recall because I want to make sure that every customer that's going to churn or is going to leave me, I want to identify all of them. So the cost of a false negative for me is very high. I want very high recall in my model. And you have to make that kind of a trade-off. It depends on the business, right? So your data scientist will not do this optimization for you. Your engineer will not do this optimization for you. You have to think very, very carefully as a business leader, what really am I trying to predict? What am I really trying to optimize? And that is what makes data science and machine learning and big data interesting in a true practical business setting. Let's move on to the 4th lesson. So as I said, if you become very data driven and you use machine learning and you hire all the data scientists from Stanford, well, your competition is probably going to do the same thing. Machine learning and big data is getting very democratized now. In the old days, few companies which were larger, they would attract the talent from computer science, mathematics, physics programs, and build sophisticated models. These were the banks on Wall Street or hedge funds, and they would have quant analysts who would build these sophisticated models. Now, with machine learning being available as a cloud computing service, anyone can do it. A 2-person startup can use machine learning and prediction inside their product. I mean, we at Google have a lot of solutions that we offer as a cloud-based solution. So you don't even have to build your own machine learning solution. You upload the data onto Google Cloud Service, and you use machine learning APIs, and you get your prediction outputs. Very, very fast, very, very scalable, and very, very cheap versus building your own machine learning solution yourself or creating your own data center to run these complex calculations. I mean, many companies, like let's say if you were a large retailer, you may have 10, 20,000 points of presence, retail outlets, point of sale, cash registers, and you are collecting real-time data from everything to decide what discount to offer, where to change the price, what new product to launch. There's a lot of calculation that you need to do all the time. Now you can do it in the cloud. That means your competition will probably do it in the cloud and will do it quickly. So it's important to kind of keep up. So what I'm sharing with you is that this is an inevitable game where everyone needs to compete and stay ahead. It's not a one-time exercise. It's not like we built one model and we have a good model and we are done. It's not going to work that way. Here's just another example. So let's say you're building some kind of a recommendation engine, right? So here's recommendation of apps on Google Play Store. You could have recommendation on Netflix, recommendation on any streaming site that you use. Now, the business that's trying to predict what's the next show you will watch, what's the next app you will download, there are many things that are going into that calculation. I mean, the company needs to think about what's the hot trend right now, because that needs to go into the prediction model. If you built your prediction model last year, well, all the top shows of this year are different. So you need to really build something that's ongoing. Your licensing costs can change. Like, let's say you are a streaming service and you bought content from a studio and you had a 2-year deal with that movie studio or that music label, and you procured the rights to stream their movies or shows or songs on your streaming service. But now when your contract is expiring, you have to renegotiate the terms, your prediction model needs to change too, because that's in your cost of false positive and false negative, right? The last lesson I want to talk about, and this is something that I really want to emphasize, is data is an asset, but data can also become a liability. It's quite common that for most companies, many companies, the data hygiene is not very good, the security is not very good, and then hacks happen. I mean, there are a few examples I have here. I'm sure you've heard of most of them. Target, iCloud, Anthem Insurance, Home Depot. So, I mean, I'm a customer of all of these. So I've probably my data has been hacked every time. How many people have access to my data, I don't know. But it's true. I mean, it happens. And whatever business you are in, whether you are manufacturing machinery or you are an online business like an app or you are a bank, I mean, you have lots of data that's very, very important for your own business, and lots of user data that you have the responsibility to protect and to prevent these breaches. So it's very, very important to create that culture where you're not lax with your data. You're very thoughtful, very organized. You have a clear culture around your team, around people, how they store the data, where they store it, what are the rules around copying the data, joining the different data sets. I mean, you have to invest a lot in making sure that your security is up to date. I mean, things get hacked all the time. I mean, if you think for your organization data could be a competitive asset, data could also become a liability if you don't safeguard it, if you're not very thoughtful about protecting that data and using it in the right way. So those were the 5 lessons that I had that I wanted to share with you. I'm happy to take into any of these specific areas and happy to share more examples as I have. So I'll open it up for discussion in the room and get questions, comments from you. I would certainly love to hear what challenges you're facing in your organizations today or what's top of mind for you.
Great. So first let's just thank
Thank you. That's the first question. My name is Mukul. I work for an insurance company. So on your topic of migrate and break fast, right? So it's a very important point. In my experience, what I've observed is that when you get to the point where your prediction model can be operationalized and productized, it takes a long time for it to mature and get to have a decision, and basically value, right? And it's kind of a very slow process. So in your experience, what have you seen in terms of how can you kind of accelerate the maturity path of any model that you can use?
That's right. So the question kind of pertains data science, we want to do predictions, but building models and creating the process around that can be time consuming and long sometimes. So my experience has been that that is true. Building good models, training them can certainly be a long process. But here's one thing that I believe that everyone should think about. You have a lot of startups in kind of your initial training your initial model, but you need to take advantage of that startup cost going forward. So after you've done your initial assessment, try to put these models into daily production workflow and create more like a learning model so that the model retrains itself pretty much every day or every minute or every week, depending upon your frequency, which is what we have done. I mean, I have personally seen that sometimes it takes many, many months to almost a year to collect all the data, build a good prediction model. But in that process, we make sure we invest the time so that you're collecting the data. You invest the time in making sure that there is a cadence around curating the data, tracking the quality of it, processes around that, and then you productionize the model. Now, when I say productionize the model, what does that mean, right? As I said, historically, people would have said, okay, I need to build a data center, I need these many machines, and I need to hire at least 6 engineers to build that model, to maintain them. I need someone on call. In the world of cloud computing, you really don't need to do any of that. I mean, there are good cloud computing solutions available today. Now, every business will have unique needs, and you may need something sophisticated that today no one is supporting in the cloud computing market. But the market is moving so fast. I mean, Google, Microsoft, Amazon, IBM, everyone is investing in this space. You guys might have heard that the Google AlphaGo, which was the artificial intelligence product that Google has created, was able to defeat the world champion in Go. Now, Go is a very, very complicated game. People thought like that will never happen, or it'll take 10 years or 20 years for it to happen. It just happened. So the world is moving very, very fast, and the research in this space is moving fast. Now, every company does not need to invent a new machine learning algorithm. These things are available to you as a service. So that can really speed up. I hope that helps. That answer helps your question. Kenji, you had a question?
Yeah, so if I were a hypothetical large company that's not very sophisticated in data-driven decision-making when you set it up, and the tools that I need are not very complex, it seems to me that the biggest barrier is first to get people's minds to change and the organization to be able to say, okay, we have a lot of legacy systems that don't talk to each other and only produce unuseful data for what you want to do. So does Google for work, or what do you think is a good way to move forward in saying, okay, here's how you build something else to find the data that you need, you can analyze it pretty quickly, and you don't need that many people. It's a new paradigm of thinking about things. It seems to me that that's the biggest jump that a lot of big companies need to do.
Absolutely. I worked for a company, consulted with a company many, many years ago. They were in the business of making cookies and crackers. So a consumer packaged good company, they make cookies that you'd buy in the supermarket. Now that company has been around for maybe about 100 years, and they've been in this business making cookies and crackers. And the way they run their business is based on gut feel, right? I mean, you think like chocolate is what will sell this year, or in back to the school season, it's going to be peanut butter. And that's how you've run the business for 100 years, and you feel pretty good about it, right? I mean, the company has existed for 100 years. So a lot of times there's that inertia, that resistance, that, well, I mean, our judgment usually works quite well, and we are very experienced, and people will come to you and say, I've been in this business for 35 years. I know exactly what sells in back to the school season. I know exactly what sells in winter, in summer. So that's the starting point. People have a little bit of inertia. They don't necessarily want to change. What usually helps them change is seeing the disruption in their market. Someone else starts to disrupt them, starts to become more data-driven, and then suddenly they have to change. So I'll share one example with you specifically. So banks have been in the business of consumer lending for 4, 5, 600 years, right? I mean, there are banks, you go to them and they look at sort of your credit history. That's the common process. You look at someone's credit history, their debt history, and then you evaluate their credit score, FICO score, and then you give them a loan, right? That's how pretty much all banks work. And I'm sure if you've gone for a car loan or home mortgage, that's the process. They pull your credit report, look at your credit score and few factors, and then just decide to give you a loan or not. So a few friends of mine left Google and started a company to give credit to people not based on FICO score or credit score or their credit report. They said we'll give loan to people based on their SAT score, their GMAT score, their GRE score, right? And they think like that's a much better predictor of whether someone will be able to pay back the loan. Or that's a good predictor for targeting a certain population that was not going to be served by the bank. So if you have a 22-year-old graduating out of college with $300,000 in debt, banks are not going to be giving that person a home mortgage, right? But if you think like, okay, their GRE score, their GMAT score, their SAT score, all of that looks good. This person will be able to pay back their home mortgage, even if they have $300,000 college loans. You may be able to capture that market. And then suddenly banks will realize, oh, we are losing that market completely, like because someone else is able to offer them a better interest rate, and their risk calculation is much better than yours because they are using data better than how you are using your data. So that's a very interesting space. I mean, and that's how when companies get disrupted, they suddenly start thinking about, okay, I need to do something.
A specific example of
Sure. So the question is about A/B testing. Now, A/B testing as a discipline has existed for many, many years. It's certainly not new. As I said, in the medical field, you do control, you give treatment to one group of people and you give placebo to the other group of people. What's happening now in the tech industry, and it's sometimes easy to do, is you have a web page or you have an app, you direct 5% of our traffic to a new site or to a new app version of the app, and then see how people react on it. So you have your web page, and let's say it's mostly green in color, and now you want to test like, okay, if we change the color of the web to blue, will it increase people spending more time on the web page? Well, you can direct 5% of your traffic to the blue color page and see if that really does increase more time spent on the site. So it's very common. All companies do it in the web space, and if companies are not doing it, then maybe they are living in the last century.
You mentioned that changing company's culture is very important. Most of management understand that, hey, data science, AI, big data is very important. But for doing this, so management need to invest in first. This is chicken and egg discussion. So, hey, show me your KPI first, for example. And the CIO maybe consulting to keep the current IT system to keep the data secure. On the other, marketing manager would like to make a data decision. What are the key success factors to change company's culture? CMO, CIO.
Yeah, I think that's a very, very deep question, right? How do you change culture, right? It's almost like how do you bring about a revolution and change people's way of thinking? There's no easy answer, and certainly I'm not an expert in revolutions. But I'll say this, that usually if you can show few examples, few prototypes, you can find best practices in your industry, and you can show to your team that, oh, you know what, we are not doing this, but one of our competitors is doing this. That's usually a pretty good factor that shakes people up. It's like, really, our competition is doing that? Okay, we are going to do that too. So that works usually. Yeah, that's right. That's right.
Maybe combined with the worst practices of other competitors. You don't want to be like them.
Yeah, so Kenji, as a suggestion, show them like the competitors that are going out of business, what they are doing, and tell them that we don't want to be doing the same thing. Yeah, yeah, okay, yeah.
So you touched on an interesting part about A/B testing question about blue color versus so in the world of data sciences and data nowadays, when you're making complex models that take months to mature and operationalize, what I've seen is that many companies have this culture of using the lean product methodology, very lean, agile, very to make a minimum viable product, then you can testing it, right? So, my experience kind of says that the concept of lean doesn't apply very well to advanced analytics models. And just wanted to hear your thoughts on what your experience is on that.
Sure. So the question is about can you build a lean, agile model for data science and for building models? So I would say this, that you have to be nimble. And I mean, is lean or agile the right word here? And which process are we talking about? It depends. Kind of every organization has a slightly different take on what's their version of lean, what's their version of agile. But I would say that as a company, you have to definitely be nimble and respond very fast. So I'll come back to my point of you have to iterate very quickly and very fast. So if your process is that we need these 6 levels of approval, we need to get extra servers, we need to do 20 tests before we launch it in production, it's going to be a slow process. And maybe it was okay in the past. I mean, that's how you worked and your business has been around for 50 years or 100 years. But things are getting disrupted much more quickly now. So it's pretty much upon all of us, I would say. Every company, like no company is perfect, is to move faster and to think about like creating a more nimble teams and a nimble process to try and experiment with new models, test something new and see how it works. If you wait for approval chains for every little change, that's definitely going to slow you down. Any comments in the back?
It seems like this process is very useful not just for companies but also governments now, right? Where we have an amazing amount of data that could be available to people should governments release it, sensors and other types of data that can be collected. There was a recent interesting article about, say, New York finding that lots of people were being ticketed in places that were legal simply because the police didn't notice that it was actually legal. The ticketers knew, but the police didn't. And it was through open data that somebody went and analyzed that discovered this pattern. So they're raking in a couple million per year with basically incorrect tickets that could be contested. But so this paradigm, this is just a comment, is as useful, I think, for governments moving forward to make good policy and for people to want to analyze various government policies to make better policy, where it's done by a third party that understands this logic.
Absolutely, absolutely. And I totally agree with your comment that data science is not just a business problem, it's also a society and a government and a community opportunity as well. To think about how we can use data to make more intelligent decisions. Maybe it's to track student progress in schools, police incidents, profiling, kind of how to measure and catch these type of things where it shouldn't be happening. Or if you notice a certain bias that's introduced in the process, how to catch that. Absolutely. And I mean, a lot of governments would make their own kind of decision and investment in this space. I know one of the kind of famous data scientists in the Silicon Valley,
after leaving the Silicon Valley firm, decided to go work for the United States government and be a data scientist for the United States government. So a lot of people do make those kind of decisions and can certainly help the government in making good data-driven decisions as well.
Since you're in Google for work, I don't know how much you can talk about your work, but as just the back of the envelope, of the proportion of large American firms, how many do you think what proportion do you think are on board with this kind of thinking? and what proportion are, say, very good at using, say, Google tools that in the cloud era thinking, and how many are not on board?
Absolutely. So the question is about what percentage of large American firms have really kind of accepted and absorbed this data-driven culture. I would say, as I said, there are three aspects of this. There is data, there's machine learning, and then there is experimentation. And it's a sequence. It's sort of like a hierarchy. It's easy to start with data first. Machine learning is slightly harder, and then experimentation discipline is a slightly harder and newer thing to do. I would say a large number of organizations have invested in the data infrastructure. And it's partly to do with there are so many tech firms out there that are selling various technical solutions like, okay, I have a storage solution, I have a streaming data collection, I have MapReduce, I have Hadoop, I have Kafka, all kinds of companies that are out there going to sell to other companies saying that you need a data strategy, you need a data solution. So what most CIOs and large organizations would do is like they'll say, okay, I'll buy this tool, I'll buy that tool, I'll collect this data, I'll collect that data. That part I'm not too concerned about. I feel the industry is moving along quite well, good progress in the industry. So step one is covered. What you do with that data in terms of doing machine learning, that I would say people are behind. Most large organizations, I would say majority of them are certainly not using machine learning as part of their business. And then in terms of experimentation, my experience suggests that it would be tiny percentage of organizations, big or small, that are using experimentation as part of their business decision making. People still go back to the gut feel idea or saying, we'll launch it, we'll see what happens, and that is our experiment.
So what are some of the common mistakes that people do when trying to experiment with machine learning algorithms? Like they're behind, like you said. So either they're behind, they don't trust it very much, or they don't have the skill. But or for organizations that do actually trust it, but they may not be able to get a lot of value from it. Like, what are some of the common mistakes people do when trying to do machine learning for their business decisions?
Sure. So I'll start with my own experience in the area of what are the common mistakes people do when they're trying to implement machine learning as part of their business. People naturally quickly gravitate towards what's the most exciting algorithm out there, right? Because you're usually asking an engineer to build a machine learning thing. So they'll say, oh, I read this paper last year at this conference, and this is going to be the best algorithm, right? Or Google launched AlphaGo to defeat Lee Sedol in the game of Go, so I'm going to use that algorithm. So people get overly excited. In my experience, most of the time, there's no need to get overly excited. Sometimes you have to make a trade-off between, do I want a fast algorithm or do I want a more accurate algorithm? If you are building something which is real time, people are coming to your website and in real time you're deciding whether you will give them a discount or not. You want an algorithm that will run fast. Even if the accuracy is a little bit lower, you may want something that runs fast, because if it runs slow, I mean, the visitor on your website is already gone. Or you are, as you said, you are from insurance company. If you have a client sitting in front of you as an insurer and you want to kind of construct a policy for them and you want to use machine learning for that use case, you want something that runs fast and gives you a result quickly, rather than saying that, oh, we'll get back to you tomorrow with a quote. Well, tomorrow that person might have gone and talked to 3 other insurance companies and maybe have gotten a good quote already. So speed may be important, and that's the trade-off we need to make. In my experience, I've noticed that people sometimes don't make that kind of a trade-off. You just get enamored by the technology and you don't think about the actual use case. We need something that runs fast, even if it's not perfect. So that's a common mistake I've seen.
If a company decides data-driven decision-making management, my question is, what should we do? Not so many professional data scientists within the company, and not so many professional data science to understand the specific industry. So do you think it should be outsourced it work out like yours?
Yeah, so the question is like if you don't have a data science group and there isn't an, it's not easy to find that talent for your industry. I think this is where generally a lot of tech consulting companies or consulting companies in general come into play. So you may have an Accenture or an IBM or Deloitte or someone like them come and help you build a technical solution where they use machine learning as part of that. They will use the technology that's powered by Google or Amazon or something. Or they could build an on-premise solution for you. Inside your data center, they put a server, and that server runs your machine learning algorithm. But as I was mentioning earlier, it's sometimes much faster and quicker to build it in the cloud. So even if you were to bring in an external consulting firm that does data science consulting, you can ask them to actually build the solution in the cloud rather than build it on-prem, so that it's not a year-long project, it's a quarter-long project.
Yeah, anyway, thank you for your presentations. And sometimes, yeah, we also, each company have a ERP and cloud system and database. But sometimes we say like a garbage in and garbage out, right? And you say that you need to spend 80% of your time or your team time for making, cleaning, and organizing the data. But how do you audit, like, if that is really, I mean, that cleaning or organizing, how do you audit, like, check for those activities?
Got it. So the question is about like if the data quality is not there, how do you really institute a process around making sure the data quality is good, and what's the governance and audit process around that? In my experience, it's been the hardest problem. It's been the hardest because it's not like one group owns all the data in a company. The data sits in so many different places. The data sits in your ERP system, in your HR system, in spreadsheets. The data sits in a lot of custom tools that you use because you have an integration with a partner or you work with another group. So it is always a challenge. How do you bring data together that's sitting in 17 different systems into one single pool, so that you can then join these different data sources to make some intelligent decision on top of it? I haven't been able to find any easy answer to it. So if I find someday, I'll let you know. But it is a hard problem. And there's no, as I said, there's no shortcut. You have to invest the time to collect the data from these 17 different systems into one place if you want to make data-driven decision. Otherwise, you make the wrong decision, like the example I shared with you. You reduce the price and you think demand is inelastic because you never collected the data from the market price. Yeah.
Because I feel like business consulting is quite important when you deal with data with a company or under how do you kind of deal with the trade-off between the algorithm and the business inside?
So if I understand your question correctly, it is how do you make the trade-off between using which algorithm to power which business insight? In my experience, that hasn't been a major challenge. I mean, there is a kind of a set of algorithms that are in the toolkit of most data science, machine learning organizations. It could be a simple regression that runs really, really fast, or it could be a more complicated solution like a neural net that runs a little bit slower but is much, much more powerful for a use case. So if I was, let's say, predicting sales, I might just use a regression model that runs really fast. Or if I wanted a quick binary outcome, I might still use a logistic regression or something like that. But on the other hand, when you want to do image recognition, you want to do voice recognition, these are fairly sophisticated problems So you're not just saying, is it a 0 or a 1, is it this class or that class? You're really trying to understand what is the person trying to say. So you're taking the voice, kind of really capturing the voice and doing recognition on top of it. Mostly you would use a neural net model for that type of a problem. So it depends on what use case you have, and you will choose the right algorithm based on that use case.
Yes, the topics here is machine learning and data science. So we kind of fulfill the gut feelings. But don't you think sometimes gut feeling is important? If somebody has been in the industry for 20 years, he probably know something. And so is that how do you balance that, and how do we incorporate those kind of gut feeling into the model?
Absolutely. So it's a very good question. Like gut feeling is very important in any business decision, right? And I would say this, that gut feeling helps you come up with good hypotheses, because even when you're running your business, you may have 2 or 3 different ideas. You're like, I think this season this could go well or that could work well, and you're not like really able to make up your mind. So you could come up with 2 different hypotheses and then use the data to test which is the right one, or set it up as an experiment and see which one works. So I'm not against gut feeling. What I'm trying to say is that if you run your business only on the gut feeling, then maybe someone else either will have a better gut feeling, or they will test all the different ideas and they'll find the one which is better than your idea. So that's one thing to kind of keep in mind. And my example about banks lending on credit score versus this company coming in and thinking about SAT score and GRE score, it's like, well, everyone had a gut feel that credit score is a good thing, and it sounds very analytical, very thoughtful, it's calculated, it's a number, it's predictive. But then someone came up with just another idea with another set of data, which also works quite well and maybe outperforms your idea. So it's good to be keep your mind open, that if there are other better ideas, you are accepting them and not just sticking with your gut feel.
Great, thank you so much for joining us.